Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Longmore 8, the Hamster Wheel Nebula. So what do we see here? Well, here at the center we see what is known as the Hamster Wheel Nebula for its distinct shape. And we can see the pinkish color there. That pink color, as we've seen before, is associated with hydrogen gas. So hydrogen gas, when it is excited, will give that distinct reddish pink color. So we're seeing that. Scattered around it, we see the blue glow, which is associated with oxygen. So each element will give off very distinct wavelengths. And this fact is what allows us to determine what things are made up of out in space. We can never go get samples of these, but we can see their light. And because light of different elements gives different patterns of spectral lines, we can identify different elements in different objects. That doesn't mean that's all the elements there, but it is the one that is primarily being energized at the time. In this case, hydrogen close in that smaller hamster wheel, and oxygen farther out. Now, what kind of object is this? This is what's known as a planetary nebula. A planetary nebula is what most stars will do at the end of their lives, including our own sun. Most stars will expand outward, becoming larger and larger. Those outer layers will eventually become unstable and be detached from the star. So the core of the star is left behind, a dense object about the size of Earth, very hot, emitting a lot of ultraviolet light. And the outer layers will continue to expand outward. And if we measured these over decades, we could watch the slow expansion of the different parts of this nebula. Now, the energy itself comes from that white dwarf, which is just the dead core of the star, but is extremely hot. And because of its high temperatures, it emits ultraviolet light, which then ionizes the gases around it and lets us see them. The fact that we see two different sections here is likely telling us something about the inner star itself, and is likely telling us that it is not just a single star. Some stars are individual stars, like our own sun. Others are in multiple star systems, which could have 2, 3, 4 stars all orbiting around each other. Alpha Centauri is one example of that. Alpha Centauri is actually a triple star system with 2 stars orbiting close together and then one orbiting farther away around both of them. So this one is likely also a multiple star system with the white dwarf star and another star both present there. But it is the white dwarf star, that extremely hot star, that is producing the ultraviolet light that energizes the entire nebula. Now, the nebula will slowly dissipate over time. It'll slowly expand and will eventually disappear as the white dwarf simply becomes too cool to be emitting enough ultraviolet light to energize the gases around it. At that point, the material remains and it continues to expand outward into space, but we would no longer be able to see it. So that was our picture of the day, titled Longmore 8, the Hamster Wheel Nebula. We'll be back again tomorrow for the next picture, previewed to be a supernova remnant. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.